This evening we'll be looking at the sine rule. We're looking at the sine rule in mathematics. Under the trigonometric ratio we'll be discussing, while looking at the sine rule, we'll be discussing derivation and the application of the sine rule. Using sine rule to solve problems on bearing, angles, and angles of elevation. But today we'll just speak on the derivation and its application. What is a sine rule? The sine rule is a formula used for solving triangles which are not right angle triangles. Now, bear in mind, right angle triangles are triangles which have one of these angles equals to 90 degrees. Now, if one of the angle is equals to 90 degrees, that means that the other two angles are complementary. They are less than 90 degrees each. Bear in mind that the sum of angles in a triangle is 180. So we use sine rule to solve problems involving triangles which are not right angle triangle. And for effective use of this, for the effective use of this, either two angles and a side must be given, or two sides and one of the angle opposite to one of the side must be known. That is only when we can use a sine rule to solve a triangle. Majorly, the triangle is an obtuse angle. The triangle is an angle which has one of its angle greater than 90, mostly obtuse angle. Now, derivation of a right angle triangle. Now let's consider a triangle ABC, a triangle which angles are ABC. We want to show that, like what we have there, angle ABC. We want to prove that A over sine A is equals to B over sine B and is equals to C over sine C. Now, construction. We draw a perpendicular from A to meet line BC. A perpendicular from A to meet line BC. Call that perpendicular H. Now, we want to use ratio of right angle triangle. If you now look at this now, we can now say that triangle AVD is a right angle triangle, and also triangle ADC is a right angle triangle. It has one of its angle equals to 90. This is 90 and this is also 90. One of the angle is equal to 90. Now, that brings us to talk about ratio of right angle triangle. SOHCAHTOA. We are talking about ratio of right angle triangle. SOHCAHTOA. What is SOHCAHTOA? Let's quickly recall. We say so means sine is equals to opposite over hypotenuse, while ka means adjacent over hypotenuse. Tua means tan is equals to opposite over adjacent. So we will be applying this in dealing with the triangle ABD and ADC. Now let's see that. Now from the diagram above, we can answer that sine B is equals to H over C, which is opposite over hypotenuse. H over C, opposite over hypotenuse. Now, if we make H the subject of the formula, we have H is equals to C sine B. H is equals to C sine B. Call it equation 1. Also, from the same triangle, sine C. If you look at sine C is now what? H over B, opposite over hypotenuse. Sine C is H over B. Now make H the subject of the formula, so we have H is equals to B sine C. Call it equation 2. Now if you equate equation 1 and 2, you'll be having, if you equate equation 1 and 2, you're having C sine B is equals to B sine C. C sine B is equals to B sine C. Now if you rearrange this, we can have B over sine B is equals to C over sine C. Now similarly again, if this triangle is drawn in such a way that the perpendicular is taken from C to meet line AB, we take the perpendicular from C to meet line AB, we will have A over sine A is equals to B over sine B, just as we have proved here that B over sine B is equals to C over sine C. So similarly, in summary, we can answer that A over sine A is equals to B over sine B, is equal to C over sine C. All is equal to H. All is equal to what? H. A over sine A is equal to B over sine B is equal to C over sine C. All is equal to H. This is called the sine rule. Remember, I said we use the rule when we are dealing with a triangle which is not a right angle triangle. And we must know two sides and a given angle, or two angles and a given side. Now, on the application of the rule, let's quickly look at this example. We are given a triangle ABC where angle B is 45 degrees, C is 72 degrees, and side A is 10 centimeters. We are asked to find C. And the first thing to do is to produce this information on a diagram. Produce the information in the diagram. Now let's see that drawing diagram, triangle ABC. Angle B is 45, C is 72, and C we don't know. Now, like I said, that the rule can only be used when two angles and a side of a given angle is known. Now we are looking for C. We are looking for C, and we only have side A, which angle is not given. So the first thing to do is to find angle A, because we know side A, but we don't know angle A. And the rule said that we must have a two angle and a side, and one of the angle which is given a side must be known. So in this B and C, no side is known, but A we know a side, so we must look for angle A. Now, in going back to sum of angle in a triangle, we know that sum of angle in a triangle is 180. That means that A plus B plus C will give us 180 degrees, which is sum of angle in a triangle. Now, what is A? We don't know. Angle B is 45. Angle C is 72. Now, by the time we sum it together, we have 119, which A plus 119 is equal to 180 degrees. So, which means A will be what? 180 minus 119 degrees, which gives us angle A at 61 degrees. Now, let's recall. The sine rule said that A over sine A is equal to B over sine B because of C over sine C. Now, we have a complete information of A and sine A. We don't have information of side B, but we have information on sine B. Now, we are looking for C. That is why we can take two at a time. We are looking for C, then we have information on the angle of C, and we are looking for side C. So, which means A over sine A is equal to C over sine C. Now, that brings us what is A from the information. A is given as 10 centimeters, sine A is 61, C, we don't know, all over sine 72. If we cross multiply, we'll have what? C sine 61 is equal to 10 sine 72, which means that makes C the subject of the formula. We'll be having 10 times sine 72 all over sine 61, which gives us C equals to 10 times. So at the end of the day, we have C is equals to 10.87 degree. 10.87 degree. Now, for assignments, which will be submitted in the next class, before the next class, we have to look for the missing side, which is side B and A. In example 1, you have angle B as 39, you have angle A as 64, you have side C as 8.5. Find A and B. And also in number 2, you have to look for B and C, given that A is 48, B is 69, and side A is 6 centimeters. We'll meet again in the next class.